Let's look at some things about exponents. In particular, we're going to look at multiplying with exponents. Some of the properties help us. First, some important vocabulary words. Monomials is a single term. When you have poly, that means more than one. So a polynomial is two more terms, but they're separated by a plus or minus. That's important because some of the things you can do and not do. For instance, if you have something like a 5x squared and you have an x underneath, part of what this section shows is that because of the fact that that's 5x times x, because it's two x's, the x on the bottom can cancel one out. But if you have a different kind of situation, like 5x squared plus y, and you have x underneath it, you can't do anything yet unless you separate the x into both of those, in which case you get 5x squared over x plus y over x. Then you can cancel these out. But you can't do it to the other, and you have to actually leave it that way. So that plus or minus allows you to put the x, it requires you to put the x with both of them. Okay. It also means, and here's a third type of thing, is if you have a binomial, like x plus 2, and underneath it you have another binomial like x minus 1, those are two separate things and you cannot change them. It's not like x can't go into x and 2 and the minus 1 doesn't go into them. That x minus 1 goes with well, it just stays there. So you have to leave it there. You could actually do x over x minus 1 plus 2 over x minus 1, but I don't think we need to go that direction or worry about it there. Okay. Instead, what we'll do is focus on the fact that if there's a plus or minus, that the variable would go with both of them, if you saw that. We're not doing any of these right now. We are sticking to this type of thing in this section, as you'll see. The constant is the ones that don't change, okay? It's not used to do anything else with. Coefficient is simply what goes in front of the variable. Get this to stay there. All right, some basic rules. These are two of the three most important basic rules of exponents. This first one, if you see this set where you both have the same base in the exponents, that means you add those as 5 plus 3, and that makes it 8. Now, the reason for that is that x to the fifth means that there's 5 x's, and x to the third means that there's 3 of them. So if you put them together that way, you see that there's a total of 8. So you can count them up like that, but it's much easier just to add them. This one, in this case, when you see an exponent of an exponent, that means you do x 5 times 3, you multiply it. So you get x to the 15th power, not to the 8th. And the reason for that is that that 3 exponent means you have an x to the 5th times an x to the 5th, because the exponent 3 means that you do it 3 times times exponent to the 5th. And then this is 5 of them, and 5 more, and 5 more, and it heads up to like the same thing as adding all of them, like up here. So it's x to the 15th by adding. We can do 5 plus 5 plus 5, which is a lot easier, or even easier to do 5 times 3. So those are the two most basic rules. The third thing has to do with negative exponents, and that's if we have like an x to the negative 1 here. That means you can bring it to the other part of the fraction and make it x to the positive 1. Or you can have it on top and bring it down as long as you change the sign. That's the most basic thing, the other third basic rule of exponents. Well, now let's look at these examples. So for these first two, 7 plus 4, that's set up to make the 11. Here you would multiply them, so it's x to the 28th. Pause for a moment and do the other 4 yourself, and then come back and I'll show them. Well, welcome back. This one, the first one here with the 11 and 5, we'll be adding those to make 16. But when it's in this format, we multiply them to make x to the 55th power. And underneath here, 12 and 7, in this format, we're adding them to make 19 for the exponent. But here we multiply them to make x to the 84th. Now let's look at the next page. And on the next page, We have variations of different types. The first one is just simply lots of multiplying. That's x to the fifth times x to the fifth to the power of 3 to the power of 2. So you do 5 times 3 times 2. 5 times 3 times 2. So that's x to the 30th power. Now, these next two are very similar, but different answers. So look at where the parentheses are and where the 4 is placed. Very important. The 4 is on the inside of the parentheses or it's on the outside. We can rewrite the first one with the 4 with an exponent of 1, which means now we're going to use the 2 to multiply to those exponents. So it's 1 times 2, and then it's also the x 7 times 2. So we have 4 squared, which is 16, and x to the 14th. Remember, if you get 4 squared, you can't leave it that way. You have to make it equal to the number or any of those exponents. So you have any numbers, you actually have to multiply. So we get 16x to the 14th. Oh, before I do that, now let's look at this next one. 4 is on the outside of it, and that means what we have is x to the 7th times 2. So the 2 goes with that 7 for multiplying, but not to the 4 because the 2 doesn't affect it. So that means it's 4x to the 14th power. And so in these two, notice that the big difference is what happens with the number, whether it's on the inside or the outside. Is it affected by the exponent or not affected by the exponent? Make sure you think about that when you're looking at these problems. Now, D, there's this just multiplying. This is multiplying in between. So we can multiply the things that are like. 6 times 3 is 18. And then x to the 5th times x to the 7th, which means we'll add these because it's both of them have a base. So it's 18 x to the 13th power. 7, 8, nope, it's to the 12th power. Make sure I add numbers correctly when I'm doing this. So 18x to the 12th. Now underneath it, now we have a complication. Look at that. One of these has an exponent. So we have to do that first. We have to take care of that. We have to apply the exponent to that one. So when we start working on it, we just leave the first one essentially alone. Well, we leave it in front. We're not going to do anything with it yet because there's no multiplier to it. But then we have to square each of the things in the second one. Negative 3 squared is a 9. X to the 7th squared. We would multiply those two numbers to make 14, those two exponents. And we multiply this one to make y to the 6th. Okay. So what we're really doing is negative 3x to the 7th, y to the 3rd, and then doing it again, negative 3x to the 7th, y to the 3rd. So the negative 3 times negative 3 is the 9. We would add these two x's to make the 14, and we would add these two 3's to make the 9, to make the 6 rather. But that would be the same as multiplying the 2 times the 7 and the 3. All right. Now we would go one step further, and now we'll work with all of these. So we would do 6 times 9 to make it 54. And then the x's, 5 and 4, make 19, and the y's make 13. Now underneath it, the last one of these example problems, we're going to need to square both things. So, or a cube. Wait a minute, this one's a cube. That one's a cube, and that one's a square. So we have to cube all the things inside there. So for the numbers, for this one in black here, 6 cubed is 216. X to the 5th cube is x to the 15th. Y to the 7th cube, 7 times 3 is 21. And then this second one is just like we did before. Negative 3 squared is 9. X to the 14th is 7 times 2, and y to the 6th. Now that we've done that, we can multiply the numbers. 216 times 9 is 1,944. And then we look at these x's, and the exponents add up to 29. And then for the y's, the exponents add up to 27. Make that 7 a little bit better. So it's very clear that it's a 7. There's some good practice ones underneath here. Go ahead, please, and do these yourself. Pause the video and come back to it, and then I'll write out the answers to each one of them, and you can check to see if you are correct. Go ahead and do that now. All right, welcome back. Let me give you the answers to these. So this one is x to the 80th power. Next, we have 343 x to the 18th power. Then we have 7 x to the 18th power. Then we have 36 x to the 11th power. Then for E, this one's negative 500 x to the 8th, y to the 13th. And to see how it becomes that, the first one doesn't get changed, but you apply the exponent 3 to each of those numbers, and you get, or each of those things in the second parentheses, is negative 125 x cubed y 12th to the 12th. Then multiplying those gives you the negative 500 x to the 8th, y to the 13th. And then finally, the last one comes to 36 x to the 6th, y to the 10th. And that comes about because the first one gets changed to become 9x squared y to the 8th because of the exponent 2. And the next one, the exponent 2, makes it 4x to the 4th y squared. And that, I'll multiply that and you get the answer here. So if you got each of these answers, you are good at this. If you didn't get them, you are now good at this because you see how to get them correctly, or go back, figure out where you might have made an error, and you can learn from that error so you won't make this the error again in the future. Okay. I hope this was helpful. Thank you for watching and listening.